Hello everybody. Let's start transitioning to doing filters with color. As you remember from our introductory lecture before, each color is represented by a 32-bit integer using a sort of a code. So if you have the integer 65,535, there's nothing about that number by itself looking at it that would tell you what color it was. What you have to do is you have to convert that number into binary and look at each set of 8 bits that represent it. And so the rightmost 8 bits represent how much blue. And then completely separately, the next 8 bits is how much green, and then how much red, and then how transparent. So if you were going to do this in a graphics class in college, I would actually teach you how you can access the bits themselves and extract just the last 8 or just the next 8 using things called bit masking and bit shifting, which is pretty cool. And if you're curious, maybe I can record another video. But for right now, in our framework, I have ways of extracting those separate color channels just with methods in dimage. So here's the general template for any type of color filter. You have your input dimage. You'll get a red channel, a green channel, and a blue channel. And so that gives you 3 separate but corresponding 2-dimensional arrays of values. So you can sort of visualize it this way. So the upper left-hand corner of red corresponds to the upper left-hand pixel, but it's just telling you a number that tells you how much red is inside that upper left-hand pixel. So each of the values in the red array can be between 0 and 255 for none of that color or the maximum amount of that color. So what you can do now is you can work with the color channels separately. You can do the same kind of stuff you were doing with black and white filters here in the middle, but with each of the arrays in parallel. And then when you're done, you reset the image by saying set color channels, and you give it red, green, and blue. Okay, so let's do a couple of examples together. You should definitely type along with me just to make sure you've got this under your fingertips. We'll start by swapping color channels, then we'll remove a color channel, then we'll add some speckled noise that are different colors. All right, so here we are. I'm going to right-click and say New Java Class. And I'm going to make this the remove red filter. And I'm not going to add it to Git. All right, so what am I doing? I'm implementing pixel filter because all the things we're doing are pixel filters. And I'll go ahead and have the process image method get implemented automatically. And I said that the first thing I wanted to do was get out each of the color channels. So image.getRedChannel, and then we'll have green is image.getGreenChannel, and then image.getBlueChannel. All right, great. And then just so I don't forget at the end, I'll say image.set color channels to red, green, blue. All right, and then I have to return the changed image. All right, so what am I trying to do? I'm trying to remove the red color channel. So one easy way to do this is let's loop over the red channel and just fill it with zeros. So I'm going to loop over red.length, and then the columns are going to go over red r.length, and I'll say red row column equals 0. So now I'm changing all the red to be 0. All right, let's go ahead and run it, and we'll see what that looks like. Oops, it's running in the other screen here. All right, so remove red. You can't see me typing because it's in my other screen. Okay, here we go. Remove red. And then when I show it, great. So you can see all that like pink in the lips and the pink in the paws has now all gotten removed from the image. Okay, so what I did was totally fine. It's a little bit unnecessary. One thing that I could have done instead is let's just replace the entire red array with a new short 2D array that's the same dimensions. So image.getHeight and then image.getWidth. Because the default value for a new 2D array is it's already full of zeros. So rather than looping, I can just allocate a new array, and it's automatically full of zeros. So that would do the same thing. Okay, let's do another one. Let's swap color channels. You actually probably can guess how to do this already, so why don't you think about it for a second. You don't need to add any lines of code here. All you have to do is change this line of code. So think about what would you do if you wanted to swap the green and the blue color channels. Or no, let's swap red and green. All right, here we go. So what I'm going to do is I'm just going to swap the order of the arguments. And what that's doing is I'm saying, let's take all the green values, but let's treat them as if they're the red values, because the first argument here is going to be used as the red values when we set the color channels. So I'm saying take green and use it as red, take red and use it as green, take blue and use it as blue. Let's run it, make sure it looks good, we feel happy. Oh, I didn't make a new filter though, did I? Okay, well, it's still called remove red filter, which is now a lie. So remove red, I've typed in the other window. Cool. So now all the pink in the lips has become green, and all the green in the plants has become pink. Awesome. So we swapped the color channels. Let's do one last one. Let's go ahead and add some color noise. So I'm going to make a new Java class, color noise. Let's say implements pixel filter. And now, all right, so we got this one. I'm going to go ahead and make a constructor where the user can tell us how much noise. So public color noise, and let's do this. Double. Sorry, I hadn't really planned this out. Okay, so string response equals J option pane dot show input dialog null enter a noise percentage, or let's say noise probability, and then we'll convert that to a double. So let's say private double n for noise probability. So then double.parse double r. All right, so here's the idea. The idea is, so noise are kind of like random color changes, color amounts. So let's do the same thing that we did before. Let's go ahead and get out the color channels. I'm actually just going to copy and paste from here, because that's going to be faster. Okay, but then I want this still to be red and green and blue. All right, so I've got the color channels. Let's see, to add noise, what I'm going to do is I'm going to loop over all the indices. So row is going to be red.length, and then column is going to be redr.length. And now I'm going to, with some probability, change the color amounts. So let's see, I'll say if math.random is smaller than the percentage, or sorry, the probability. So this is sort of like testing, should we create noise at this particular pixel? So if my random number is less than the percentage or like the probability of creating noise, then I'll create noise. And the way I'll create noise is I'll create a new amount of red, green, and blue. So red at row column is going to be a new short, which will be math.random times 255. I guess 256 actually, because we want to be able to get 255. And so if we make this 256, then the largest integer value, or the largest short we could have, would be 255. Okay, so let's do that, and this, except this is going to be red and green and blue, because we want our color to be possibly any value. Okay, so I guess we're ready to run it. Let's try. What did I call this? Color noise? Okay, here we go. Over here, I'm typing color noise. Enter a noise probability. Let's do 50%. Oh, and I get a null pointer exception. Sweet. Check out my null pointer exception. Under draw, oops, sorry, wait, let's go back to the, wait, what? Cannot invoke DImage.getWidth. Okay, hold on. Okay, cool. Well, that makes a lot of sense. So here I'm returning null, and null is the image I'm supposed to be displaying. So really I want to return image. I should probably change in my framework to have it display a more sensible message when that happens. Okay, let's try this again. Oh, sorry. So you see I've changed some things because I was debugging. Oh, well, all right, hold on. All right, we're doing it all over again. This time, we hope it will work. I'm typing color noise. It's saying what's the probability. I'm saying 50%. Ah, great. And so there's a lot of color noise. And if I unpause it, what's happening now is I'm running the filter repeatedly as fast as my processor is able to, so probably about 30 times a second. And then I can pause it again. Cool. Okay, so from here on out, go ahead and implement the filters for today, and then there's going to be kind of a bonus extension filter next time.